Hello and welcome to C++ Weekly. I am your host, Jason Turner. I am available for code reviews and on-site training. In this episode, I'm going to talk about the difference between what happens if you move an object and then call a member on it versus if you call a member on the object and then move the result. So be sure you stick around. This week's episode is sponsored by HRT. If you've attended any C++ conferences this year, there's a good chance you've already heard of HRT, as they have sponsored several conferences. HRT is known for its deep engineering culture and strong focus on performance, and they are looking to hire the sharpest engineers to help them to develop and optimize the technology at the core of their business. They're headquartered in New York, but they have offices in Austin, Chicago, Boulder, London, Dublin, and across Asia. They're looking primarily for C++ and Python developers. I know, since you're a viewer of C++ Weekly, you are a C++ programmer, and you probably already program in Python too. So go ahead and check out the link on the screen for openings that they have. And remember, you don't need a financial background, just strong engineering fundamentals, and they'll teach you the rest of what you need to know. These two operations, at least theoretically, can have fairly significant meaning, largely dependent on what the object that we have does. It possibly has multiple different overloads for these functions. Let's take a quick look at standard optional. I think it's relevant here. It has an L value reference qualified member and an R value reference qualified member for both the const and non-const versions. Let's go ahead and play with it and see what we get back. Let's go ahead and establish something really quick here. A moved from object in the standard library is not required to be empty. It is required to be in a valid but unspecified state. Let's just go ahead and output this data. And then we're going to move it. And then we're going to output that data again. All of our standard library implementations do the same thing, and that is that the moved from string is going to be empty. So it's not required to do that. But let's go ahead and just be aware that that's what it's going to do. And you can see here that it has nothing printed. All right, we're going to now create an optional, and we're going to put a string in it. We're going to call this thing just optional. That's fine. Now let's create another optional. And we're going to see whether or not we actually moved out that object, that value, that string from this thing. And we can see that we did. We got nothing printed here. So what did we exactly do? We're picking the R value reference qualified member here. I think I need to demonstrate more specifically what this code is actually doing with our own object. Let's do that. All right, goodness. I made this example more complicated than I expected to, so let's just go ahead and create a holder object. I'm expecting to see the nothing printed here. Yeah, nothing printed. Okay. If I call holder.value, then I should see the non-const L value reference overload called. There we go. The non-const L value reference is called. If I call move on the holder and then value, now I'm expecting to see the non-const R value reference overload. Great. Okay. And if I call move on holder.value, I'm going to see just the non-const L value reference version called again. I'm ignoring return value. That's great. Yes, ignoring return value. We should actually do something with these things to make a point here. I'm going to create several different objects. Okay. This is going to be copy assignment. Then I'm going to create O2, and I'm going to expect move assignment here. And I'm going to expect move assignment here as well. And what we're going to see is that the end result of all of these different choices ends up being basically the same. Oh, sorry, move constructor, not move assignment in those cases. Copy constructor, move constructor, move constructor. If I wanted to get the move assignment called, then I am going to need to actually assign these to an existing object. So that will be copy assignment. Let's see if I got this correct. I did. So the end result of all of these operations ended up being the same. If we go back here, move of object.foo versus move of object.foo, if the class has reference qualified members, the result is the same. It's kind of like in this one, I'm asking nicely, please give me your object. And in this one, I'm saying, I am taking your object. Let's go back to our holder. And let's get rid of these reference qualified versions to make it more realistic to what perhaps you tend to write in your code. Now we're going to see something very different. If I call move first, then I'm not going to actually get the move construction and the move assignment. I'm going to get the copy construction and the copy assignment. And we can see here, copy assignment, copy constructor, copy assign, copy constructor. I don't get move constructor and move assignment unless I steal. So if the class has reference qualified members, then the result is the same. If it doesn't, and I want to take ownership of the thing, then my only option is to steal. Let's consider why you might want to go ahead and provide these reference qualified overloads. We're going to do this. We're going to write a function, just simply going to return a holder. I'm going to call value on this temporary. Now what I'm going to get is the regular non-const version is going to be called, and then I'm going to get a copy constructor. So when I call .value, the only option that I have is to get back this thing that is an L value reference, and we cannot get an implicit move from this. So we actually are going to want, for the sake of efficiency, if you're making an object like this, like optional, you're going to want to go ahead and provide all of these reference qualified versions, or of course, use deducing this in C++ 23 with forward like. Now note here, I get the implicit move constructor happening, and that is in fact what I wanted. Now I do think there's an additional philosophical question to ask if perhaps you actually want to return this thing by value. And then you're going to get, well, still get the move constructor. I'm getting extra warnings, interestingly, because this thing is now constructed from a temporary. This is worth talking about on site when you bring me to your company, because, you know, I have to save some things to talk about when I'm being paid to teach, but I will say that this value is constructed from the remove of, and this thing is giving a name to a temporary. So you're going to get the exact same result in your code. Anyhow, I hope that kind of cleared things up here. Let's make one final note. We do want to provide those reference qualified members to make all of this more automatic. I'm going to add this unqualified version here just to show you one last thing, and that is that our value references really aren't magic. Let's go back to this whole question of stealing the values. So I'm going to call unqual here, and that means I'm going to get a copy construction of the held thing. There we go, copy construction of the held thing. I can still go ahead and just choose to cast that thing to an R-value reference, choose the move constructor, and get a move construction. Nothing's stopping me from doing that. Anyhow, this episode kind of went all over the place, but hopefully it was interesting and gave you some things to think about. Perhaps maybe I went a little bit too much in the weeds, but I'm going to go ahead and put a link to this, as usual, with the show notes. So be sure to check it out and be sure to play with these things on your own. This is by far the best way to learn about this stuff. Thanks again for watching this episode of C++ Weekly. I will catch you in the next episode.